Hi, everyone. Welcome to today's LifeRay Live event. My name is Parneet. I am a part of the marketing team here at LifeRay. I will be your host today. Thanks for joining us for the first webinar of the series, Demystifying Machine Learning. Today's topic is the role of machine learning in digital transformation. In this webinar, you will get an introduction to machine learning and how it's changing the world around us. You'll get to learn how machine learning helps businesses in solving business problems and meeting objectives, how machine learning makes sense for your business, and where do digital platforms fit in with or without machine learning. If you haven't checked out all the other webinars from this series, there is a link in the chat window for you to check them out. Chris Patefield will be leading this session today. Chris is our senior sales engineer based out of London. He's been involved in digital transformation projects for almost 2 decades now, and he has a keen interest in blending the latest of machine learning services with JavaScript UI and LifeRay Java services. Before we dive into the session, I would like to briefly introduce LifeRay to those of you who are new to us. LifeRay is a 10-time leader in the Gartner Magic Quadrant for Digital Experience Platform. We make software that helps companies create digital experiences on web, mobile, and connected devices. Our platform is open source, which makes it more reliable, innovative, and secure. We try to leave a positive mark on the world through business and technology. Thousands of organizations in financial services, healthcare, government, insurance, retail, manufacturing, and multiple other industries use LifeRay. Some of our customers include O2, Airbus, Allianz, and many more. Just to let everyone know, today all attendees will be in listen mode. If you have any questions during the presentation, please type them on the chat box on the right-hand side, and we'll have a short Q&A after the end. Over to you, Chris.
Thank you very much. So yes, my name is Chris Patefield. I'm the Senior Sales Engineer for LifeRay UK. So today we're going to be talking about the role of machine learning in digital transformation. So I'm going to start with a bold statement. So I believe that the seamless high-speed delivery of content and information, getting the right applications, the right data, the right content in front of your customers' eyes as fast as is humanly possible is the latest digital experience battleground. Now, I need to back that up, but before I back it up, what I need to do is I need to demystify machine learning. And we can do that through the medium of Little Mix and Jazz. So there are two different types of machine learning. There's supervised learning and there's unsupervised learning. And if we think about supervised learning, we can think almost of a known formula. So we've got Little Mix. They're a four-piece girl band, not the first four-piece girl band by any imagination, but you can see that there's a way that you put that band together. So if we look at an example, which is how long will it take me to drive home, then on that we know what the input and the output is. So we know that essentially the inputs might be things like the time of day that I set off, okay, might be what the weather is like, might be whether the schools are on half term or not. So they're known inputs, and we know the output over many, many journeys, okay, with the time it takes for me to drive home. Now, that algorithm or those algorithms that are working on that data, okay, they are known as supervised learning algorithms. And there are many examples of supervised learning, such as image recognition, speech recognition, natural language processing. So the ability for me to be able to either speak or write a sentence, and for the algorithm to understand my intent. Okay, so what I intend or what I want from that statement. Not that, it's a bunch of words that can be translated, but what I actually need at that point in time. And also, it's probably accurate to say that 90% of most machine learning systems are actually supervised learning. And then we've got the other side of the coin, which is unsupervised learning. And you can think of that a little bit like jazz. So you get a bunch of guys into a room, skilled musicians, they all play completely different tunes. And at some point in time, that all melds together to get the end product. Okay. It's free form. Okay. The algorithm is unknown, or the theory is unknown, until which point you get an answer. Okay. So with unsupervised learning, you only have the inputs, okay? And the inputs are often what I call unstructured. They are unlabeled. So the data sets are normally very, very large, okay? And of many, many different formats. And then things that we can do is maybe look for a group of shoppers based on browsing history or buying history. And then by using that method of machine learning, then we can do things like suggestions. So people bought A, B, C, D over many, many years. Okay, what would you buy because you are like them? Associations, classification, categorization potentially. The extraction of data, which is actually my favorite thing. So if you can then pump in a load of unstructured, unlabeled data, and then pull out a fully structured database, which I can then potentially query with SQL, then that is a very powerful capability. So many use cases of unsupervised machine learning, such as the likelihood of a loan default, they tend to be actually, weirdly, both supervised and unsupervised. Okay, so sometimes they have structured data, sometimes they have labeled data, sometimes the data is unlabeled. And we call this semi-supervised. And there are many low-level tools that you can use in your business to create your own models, okay? And these can be used by a data scientist potentially. So you've got PyTorch, you've got TensorFlow that we actually include in LifeRay. We've got MXNet. So we've got a number of different low-level tools that you can use. Whoa, but we need to hold on a minute, right? So you don't need to be a data scientist, okay, in order to get benefits from machine learning, okay? You don't need to have the headache, okay? And what you also need to ask you the question is, all right, it sounds great, Chris, but it sounds like, you know, a load of buzzwords. So what do we need to do? So we need to tell you why you need machine learning. So now, I am a child of the late 1980s, early 90s, and I always used to be a massive fan of the Transformers. Not the new Transformers like you see in the films now, but the old Transformers, they were the coolest. Okay, and I used to wait a week, literally a week, for my Transformers fix, which was the Transformers magazine Marvel comic. I used to go down to the newsagents, pick it up. And then I had to wait almost 4 years of comic reading to watch Transformers the movie. And then we fast forward to the present day. And my children, I've got two children, two boys, they can consume around 3 or 4 different video sources and gaming sources all absolutely simultaneously. And the interesting thing is, they never actually search for any of it. So from an early age, we are being trained to consume without thought. And it's all down to machine learning. I would argue that over the next couple of years, the very concept of search, many different IT users just won't know what it is. They will just expect to turn on the interface, to access the interface, and be given exactly what they need. And many of you may have thought that UX was the battleground, right? So that's what LifeRay does. That's what many of our competitors do. But it's not all about UI. So you need to stop focusing purely on UI and use machine learning to improve your customer experience. So let's go on to some interesting use cases of the technology. So one of my favorites, and I'm looking at my colleague here, and she's not one of her favorites, which is what I call next generation web moderation. So what we can do now is we can use ML services to moderate images, posts, blogs, statuses, okay, in real time. And by doing this, we can reduce the amount of human effort and the costs associated. So we can use things like image recognition. So we can recognize images, we can categorize them, we can tag the content so we know what the image is and what it means, okay? And we can even use OCR to get maybe text from that image and then get the intent of that text. And we can even do things like celebrity recognition and product placement violations as well, or maybe someone's using a trademark where they're not allowed to. We can combine all that together on an image basis and then know whether we should accept that image or not, as the case may be. And we can use natural language processing to do exactly the same thing when someone writes a blog post or they write a status. And where we get really clever is we essentially make the model better. So and most machine learning algorithms will do this, you call a service and you will get back a probability of the machine understanding the correct results. Okay, so it will say, I am 95% sure that something is something. So what you can then do is if it's 50%, 60%, 70%, you can then send that to be human moderated. And when the human says whether it's correct or not, we can use that data to improve the model. Okay, so it's continuous learning, not just learning from the single model of data that you give it at that point of time. And then we can also use machine learning to create structure from chaos. And this really is my favorite. So I was at AWS a couple of weeks ago, over there in Las Vegas. It was a lovely trip. And what we found was we had a company there that were essentially monitoring shipping containers as they moved around the globe. Now you'd think that a shipping container would have like a beacon on top of it and would be tracked automatically through the powers of magic. But that's actually not the case. What happens is some guy just signs for it, they sign their name, and then it's like a bit of paper that then just gets lost or goes into some system and is never catalogued. So what they were doing is they were taking all those invoice, shipping bills, receipts, etc., and they were uploading them into a digital experience platform like Liferay. But as they were doing it, they were sending it off to machine learning to take that unstructured, unlabeled data and create a structure out of it. So they could then essentially track these different containers around the world and understand, again through machine learning, what the best routes for those containers should be. So it's possible using machine learning to take random data sources and create structure where no structure previously existed. Another one is predictive maintenance. So very big in the manufacturing sector. Liferay has many manufacturing customers. And what they're using machine learning for is essentially looking at the entire ERP chain, so the entire production of a widget. And if a machine, which normally has sensors in, the machine that normally has the sensors in will say, okay, I've rotated my cogs, you know, 1,000,000 times, and therefore I need to be maintained. Okay, but what they can do now is they can look at the entire chain, look at past errors with machinery, and they can almost say, well, what we will do is we will maintain that machine, okay, before the machine tells us it needs to be maintained, and therefore keep a near 100% manufacturing process. And we're also seeing vendors like Elasticsearch and many of the AWS and Google Cloud Analytic companies that are doing a similar thing. What they're doing is you have an API where you feed in your logs, your reports, your events, okay? And then that will tell you automatically when potential events may occur in the future with your computer systems. And that becomes very, very important because it can tell you what the events leading up to the errors are, as opposed to just, well, reacting to when something goes down. And then Walmart, okay, so not the sexiest retailer out there, but they need to compete with Amazon. And the one thing that Walmart has that Amazon doesn't have are physical stores. So they're using machine learning and complex algorithms to improve their shopping systems. So it includes like kind of smart shopping collection systems. It includes better ways to pay online and then collect in store. Okay, and they're integrating all this into their physical and digital estates. And what we're finding is as well, they've gone a step further. So they are using machine learning by the use of feeding video, and they're looking at the behaviors of customers. So if a customer is looking a little bit dodgy, okay, use an English word, maybe they look like they might be stealing something, okay, they look for that behavior and they map that behavior. And then they use it to try and track people stealing from the stores. But they're also using it for a good way as well, which is they're looking at people's facial expressions and looking at the way that they handle themselves within queues. And that will tell them not whether I've got 3 people in the queue and I need to open another till, but I've got 3 people in the queue, some of them are not happy, and therefore I need to open a till. And the two are very, very different. And it's a way for Walmart to save money and improve customer experience simultaneously. Okay, so, right, I think we all know that we need machine learning. We've got examples of customers and companies using this real time out in the market. It's not just a buzzword, right? It's real. But you don't have the skills to implement it. But that's not a problem, because our good friends at Google, at Amazon, at Microsoft Cognitive Services, and IBM Watson, they've commoditized all this machine learning stuff. Okay, the chances are for most use cases, especially the use cases that are going to drive value, okay, they've commoditized it. So there are so many different services that you can consume today, provided, I'm not going to tell you which ones provide which, because that would be unfair, okay? But they provide the services pre-built, which you can use today. So you've got chatbot platforms, you've got speech to text and text to speech. You've got the ability to be able to extract entity information. Example of this is you've got a chatbot, and in the chatbot, someone writes, I want a pepperoni pizza. Well, pizza is an entity, pepperoni is an entity, okay? And then you can then map that into an order journey. You've got the ability to be able to auto-complete, right? So we've all seen this happen. You've been on your Gmail, you type something, and then it automatically goes, well, this is the end of the sentence, okay? And I use that all the time, mainly because I'm a terrible writer. Voice verification, voice emotion, so the ability to understand when someone's nervous, like me presenting this. Inappropriate content, low quality audio, and the ability to even analyze what someone's personality is based on how they speak and how they write. And then for video recognition and image recognition, we can do scene detection. Okay, so we can understand the context of the scene that the user is in within the image. We can do facial recognition. We can do facial analysis. We can flag inappropriate content. No need to go any further. We can flag celebrity recognition. We can do trademarks, okay, and violations of those trademarks, and potentially do text recognition, so next generation OCR. We've got the ability to take my horrible handwriting and understand what that means. And we can even do landmark detection as well. And then when we start looking at kind of unstructured data as well, then we start getting into potentially CMS use cases, data, commerce, and content. And then we can do things like suggestion. So you can actually use Amazon's suggestion algorithms to suggest content on your own websites and your own solutions. You can do pattern analysis, categorization, tagging. We've already talked about that before. The ability to be able to create groups where no groups existed, group customers based on the data as opposed to what you think you know about them. Intelligent code recommendations, I think we could all do with a bit of that. Personalization, forecasting, fraud detection. Again, you can use Amazon's own fraud detection services within your own product. Simple translation. So the translation tools are getting much, much better than they have ever previously been. And if a service doesn't exist, then potentially you could use either Google AutoML or Amazon SageMaker that essentially allow you to build your own models from your data and then run machine learning algorithms against that data. And you don't necessarily need to be a full data scientist in order to do that. So you can take a normally skilled developer or a business analyst and create your own machine learning. So in LifeRay, we believe that the best digital experience platforms will allow you to extend the platform and integrate with best of breed. So what we don't do is we don't give you all our machine learning technology. We say, pick what you need from the best available on the market. And the reason we can do that is because LifeRay is extremely extendable, okay? So document management capabilities that we have in the product and digital asset management. So we have extension points in the product that will allow you to send documents anywhere you want into these machine learning services and then use the data that comes back, okay, to enhance our DXP. And we can react to machine learning intents and probability estimations as we do that. And a good digital experience platform should allow you to do exactly the same. So to sum up, everything or most of what you need is available out there, pre-built as a service that you can consume. This idea of, consuming microservices. So we believe that flexible integration capability is the gateway to machine learning benefits. You need to build your products as modules, okay, using a platform like LifeRay, and then you will get the best from that by doing so. Thank you very much. That's just the start. It's the first one in the series, okay? We have included the other ones in the series as well, so you can then sign up to those.
Thanks, Chris. That was a really insightful session. I can see here that we do have a few questions from the audience.
Thank you.
I can go ahead and ask you the first question. So what is the difference between unsupervised and deep learning?
So it's a very good question. So essentially, deep learning is yet another subset of machine learning. So supervised and unsupervised machine learning can also be examples of deep learning. So deep learning tends to use a different set of algorithms which are focused on continuous improvement of the data set, and also where models kind of move towards using neural networks as opposed to kind of fixed data sets. So it's a very complex question, okay? And happy just email me and we can go through it further.
I guess so, yeah. I have another question, which is something that I would ask as well. What is the difference between AI and machine learning?
No, it's again, but they're basically the same thing, right? So you've got AI, okay, and machine learning is a subset of AI. Where, and this is my belief, where AI comes together is where you use machine learning and you use, so where you use machine learning, but you also use decision trees simultaneously, or logic gates, okay? So when you put decision trees, logic gates, and machine learning together, then I believe you get into AI.
Oh, I see. And I think we have another question here. What type of algorithms aren't machine learning?
So again, I mean, an algorithm for me is not machine learning if you're using decision trees and logic gates. Plus, there are a huge number of known machine learning algorithms that you can use in tools such as PyTorch, TensorFlow, etc. Okay, and those are the examples of machine learning algorithms. Okay, yeah. So that would be the answer to that, I think.
Great. If you guys have any other questions or you need any other answers to some of the questions that you have, you can feel free to email us on marketing-uk@liferay.com and we will answer those questions for you. As Chris mentioned, we have a few more webinars in this machine learning series. So the link is in your chat window. Please go through it and register if you feel that will be of use to you. Thank you all for joining today. I hope the session has been valuable for you. As a reminder, we've recorded this webinar. We will be making it available through our website and through emails for those of you who've registered. We look forward to seeing you again next week at the same time. Have a good day.
Thank you very much.